Hello and welcome back. Today we are going to continue our conversation on slope and learn about slope-intercept form. So our objective for today is I will be able to write a linear equation in slope-intercept form. Now slope-intercept form is when the equation is in the form of y equals mx plus b. Now let's label and learn about what some of these variables mean. Now we already know that the m is slope. We've been talking about slope for a while now. We already know that m is slope. There we go. So we're going to draw an arrow to m equals slope. Now the x and the y, those are our points or our ordered pairs. So x, y, those are ordered pairs. These are the numbers, or these are the variables that we're going to check ourselves with to plot points and to see if these points lie on the graph or on the line. And then B, this one's new. This is called our y-intercept. Our y-intercept. Now, the y-intercept is the point that the line crosses the y-intercept, or the y-axis rather. The point that the line crosses the y-axis. So let me change that. Instead of y-intercept, we don't want to use the definition or the word in our definition. We want to use the word axis, the y-axis. Okay? So, our graph. So if we were to graph this equation, the first thing that we're going to do is plot the y-intercept. So y equals 2/3 x minus 4. So first thing that we're going to do is plot the y-intercept. Now the y-intercept, as we remember, if we're looking at this equation and we're looking off of our y equals mx plus b as our example, yx plus b, so our y-intercept is -4. Now, you can think of it this way, is if it's our y-intercept, that means that the y is going to be 0. So think of it as -4, 0, this point right here. So when we graph this, 1, 2, 3, 4, the y-intercept is right there. Okay, now to graph the rest of this, we use the slope to plot the points. Well, the slope is this 2/3 right here. All right, so rise over run. We're going to go up 2, 1, 2, over 3, 1, 2, 3. Up 2, 1, 2, over 3, 1, 2, 3. Okay, and then we just connect the dots with a straight line. That's how we graph our slope-intercept, or y equals mx plus b. Okay, there's another thing that we can use this equation for. We could say a point test. So using the equation that we just were working with on that graph, we're going to say, is the point 12, 4 on the line? Well, instead of having to go, rise over run on this graph to make it so it gets all the way up to 12, we can just plug it in. So let's use the equation that we just used, y equals 2/3 x minus 4. So we're going to plot it on the line. So let's just plug in the numbers. So 12 is x and 4 is y. So we can kind of make a note, x comma y. All right, so 4 is equal to 2/3 times 12 minus 4. Okay, so now let's solve this to see if we get an equivalent equation. So 4 is equal to now 2/3 times 12 over 1 minus 4. Okay, so 4 is equal to, well, 2 times 12 is 24, divided by 3 minus 4. Okay, 24 divided by 3 is 8, minus 4 is 4 equal to 4. So is 4 the same as 4? Yes, they are the same, so that means yes, that the point 12, 4 is on the line with this equation. All right, let's try it again. And now pause this video and try it by yourself and then resume it to check your work. Okay, so I hope that everyone checked it. So we're using the equation y is equal to 2/3 x minus 4. This is just the equation that we used with the previous graph. All right, so is -16, -6 on the line. All right, so -6 is equal to 2/3 times negative 16 minus 4. Okay, so negative 6 is equal to 2/3 times negative 16 over 1 minus 4. Negative 6 is equal to negative 32 over 3 minus 4. Okay, and then that comes out to negative 6 is equal to negative 14 and 2/3. Are they the same? No. So since they're not the same, they are not on the line. Okay, so let's look at a word problem. So we can look at a word problem and we know the rate and the starting amount or value. We can write an equation in this form. All right, so let's look at an example. An airplane with no fuel weighs 2,575 pounds. Each gallon of gas added to the fuel tank weighs 6 pounds. Okay, so we want to write an equation that, depending on how many gallons of fuel there is in the plane, how much is that plane going to weigh? All right, so remember that we want to put it in the form y equals mx plus b. All right, so let's take a look at this. Well, let's take a look at the rate, and then we want to know the starting amount. All right, so b, or the y-intercept, is the same thing as saying the starting amount. So an airplane with no fuel weighs 2,575 pounds. All right, there's our starting amount. And our rate is each gallon of gas added weighs 6 pounds. So each gallon weighs 6 pounds. So with that information, we know that y is equal to 6x plus, because it's a positive, 2,575 pounds. Okay, so that's our equation from this word problem. We'll work on this later as we continue to work on slope and slope-intercept form. All right, so just as a reminder, when we look at word problems, we want to look for keywords. So slope tells us the rate of change, so we want to look for the word per. Okay, per, or in the last example it says each gallon of gas, so per gallon it weighs 6 pounds. Okay, and the y-intercept tells that one-time amount. So if you're thinking about businesses, a startup fee is a one-time amount, or the last example, the plane weighed X amount before we put any fuel in. So those one-time things that not going to happen every single time, that as the months increase or as the gallons increase, this amount is already happened and it's never going to happen again. It's one-time amount. That's the difference between slope and proportional relationships. Slopes can have that one-time amount, proportional relationships cannot. Alright, so don't forget to ask 2 questions about this video, and as always we are going to go over this in class and to expand on it and to dig deeper. So thank you for being good active listeners, thank you for taking good notes, and I will see you in class.